That's what radio astronomer Anna Kopinska called the image of a massive enigmatic blob she initially detected in 2019. Billions of light-years away from our planet, it seemed like a spectral ring of smoke, a glowing anomaly of radio waves that didn't seem to match up with any recognized supernova remnant or galactic encounter. What in the world in the universe could this be? It might have been odd, but this object was not singular. Called odd radio circles, or ORCs, the objects we have discovered appear to cover all of what we can't explain in the universe. 5 ORCs have been established since Kopinska's initial discovery, and a few more blobs might be a fit. What cosmic power is so intense that it could sculpt a ring of energy a million light-years wide, so vast it dwarfs our Milky Way by a factor of 10? Are these radio rings the relics of galactic rebirth, or the dying echoes of something we have yet to comprehend? And why haven't we found more of them? Join me today as we attempt to unravel one of modern astronomy's greatest mysteries and expose the 4 top hypotheses that may unlock the origin of these objects so peculiar they break even the universe's rules. The EMU Project. This enigma initially started as a product of contemporary technology. During the onset of the new millennium, technological innovations in radio astronomy significantly raised the number of detected radio sources from a few 100,000 to a few million. For decades, nobody was able to significantly increase that number, that is, until recently. Radio astronomy was due for another upgrade, and Australia's National Science Agency, the Commonwealth Scientific and Industrial Research Organization, oversaw the launch of the revolutionary Australian Square Kilometre Array Pathfinder Telescope, or ASKAP, one of several new radio telescopes going live at the time. With 36 radio dishes, each one being 12 meters wide, what's so special about the Western Australia Radio Telescope is that it has a phased array feed which lets it image vast regions of the sky simultaneously, as opposed to the last generation of radio telescopes. ASKAP has a field of view of impressive 30 square degrees, the equivalent of the area of approximately 150 moons as viewed from Earth. The phased array feed enables astronomers to disregard radio signals from objects such as satellites, which can otherwise produce blind spots for the receivers of radio telescopes. With this new generation of telescopes, radio astronomers can pick up even weak scattered objects. Western Sydney University professor Ray Norris of CSIRO, subsequently heading the initial ORC discovery, forecast that the Australian telescope's evolutionary map of the universe project, or EMU, would be included in an unprecedented boost in our understanding of radio sources throughout the universe. The project takes its name from the EMU in the sky, a dark nebulae not star constellation, not stars in the Milky Way galaxy, that has been recognized for generations in Aboriginal astronomy. All of the radio sources found up until then by all the radio telescopes in the whole history of radio astronomy totaled some 2.5 million sources, and the EMU project alone was to boost that number to 70 million radio sources. Keep in mind that's only the findings that were anticipated to derive from just one of the new radio astronomy telescopes. Norris was sure that all of this fresh data would hold some significant surprises, and they did even earlier than anyone had anticipated. The EMU project surveyed vast sections of sky, discovery that no other telescopes had yet imaged, and gathered enormous catalogs of data, so much that scientists thought they would need the assistance of machine learning to sort through it all. But it was while browsing through some of the project's early images that Kopinska, the radio astronomer who made the find, would first see the peculiarly shaped radio emissions with her old-fashioned human eyes. To me, that makes this discovery all the more unique. Even with huge quantities of data and machine learning software, this is an example of how human curiosity will always be a part of the scientific process. Browsing through these early EMU images, Kopinska couldn't match up with any recognized space object. On an image of one of these strange shapes, a ring of radio emissions like a humongous smoke ring drifting around in far-off space, she wrote the title WTF, containing just how confused this was. Kopinska had never come across anything remotely like it. It wasn't long before she took this weird find and shared it with colleagues, when a group of radio astronomers, with Norris and Emil Lensch, set about sorting through the images in search of more of these circular radio blobs. Lensch discovered a second blob a few days later after the first one, and the team later gave them the name odd radio circles. Initially, they weren't even sure whether or not these were actual objects, or perhaps some sort of artifact or glitch in the telescope. But they could use the other telescopes to pin down the ORCs to see if these strange radio circles were legitimate. The question that arose was naturally, what are these things? Luckily, we've been able to learn a bit more about ORCs since Kapinska first noticed one. The first ORC. This is an image of ORC-1 from the EMU pilot survey, a blurry grayscale blob. But luckily, the EMU team also produced this second colorized and enhanced image that helps to bring out less obvious features, yet retain the original resolution. In the color image, ORC-1 now looks like a misty green-blue blob. Since this misty blob is only really visible in radio wavelengths, the color in this image had to be included in, so that we can visualize it. It also enables us to view more defined features within the ORC structure. 1 billion light-years into deep space, early estimates placed the diameter of ORC-1 at approximately 1 million light-years across, but more recent observations have suggested that it might be as wide as 2 million light-years across. That's 20 times wider than our own galaxy. So we have an idea of how large ORCs might be. What are ORCs? And how far away they are, but what are they? Some initially assumed these peculiar rings could be the remains of a massive supernova, but the conditions were completely wrong. To begin with, we usually discover supernova remnants close to the galactic plane, and all of the ORCs we found are too distant from it. Not only that, but it seems like some of these ORCs may have galaxies at their centers, which is not something we encounter with supernova remnants. What's more, the scale is all wrong too. Most supernova remnants are a few dozen light-years across, but these ORC rings are far, far larger. Big enough to encompass entire galaxies at their center, the ORCs we've observed so far are hundreds of thousands up to 2 million light-years across. These are not supernova remnants. ORCs must be something else. ORCs may also be something that we already know, such as the jets from a radio galaxy. But the great distance, or perhaps a peculiar angle, may hide our ability to recognize them. Since the discovery of ORC-1, astronomers have had the opportunity to see it using other telescopes showing an object, which is located at the center of the circle that may be visible in both infrared and visible light. Utilizing the South African Meerkat radio telescope, a 64-receptor array that is connected, Norris and his colleagues looked at ORC-1 for 10 hours to build a picture of the circle. They overlaid that over optical data from the Dark Energy Survey to expose an elliptical galaxy in the center of the ORC. With this, they were able to estimate the distance of the central galaxy from Earth, about 5 billion light-years away. Not only did they discover this central elliptical galaxy, but the high-sensitivity picture also showed a tangled inner morphology of knots and arcs, with further galaxies at these knots. If Norris's team and he are on the right track, and this elliptical galaxy is actually close to the center of ORC-1, then it could have had something to do with making this radio circle. But it's also conceivable that the galaxy's position is a chance, since it might simply lie close to the apparent center of the ORC, but not the real center. With this new image and data in their paper in 2022, Norris and his team thought of 3 possible origin stories for the ORC, with data neither favoring one hypothesis over another. Hypothesis 1. Cataclysmic event. The first option was that ORC-1's ball-like shell resulted from a cataclysmic event in the elliptical host galaxy, such as the collision of 2 supermassive black holes, say. In this case, a supermassive black hole merger would release a shock wave outward in all directions, accelerating electrons in the intergalactic medium. This could result in a bubble of radio emissions, which could appear to us as a circle of radio emissions with a brightened edge or ring. If this were the case, we would expect the ORC to contain a supermassive black hole or an active galactic nucleus. And not only does ORC-1 have signs of a radio-loud galactic nucleus, like we would predict if this hypothesis were true, but so do two other observed ORCs, giving further support to this hypothesis. The second suggestion given by Norris and his hypothesis 2, Jet's team for the origin of ORC-1, being that it might simply be radio jets from a radio-loud active galactic nucleus, or AGN seen endon. Radio-loud AGNs are a class of galaxy that produces high levels of energy from its nucleus in the form of two plasma jets as matter accretes into a supermassive black hole at their center. And as I said, we already know that AGNs are there in many of the ORCs we've observed so far. If we were to observe this type of system endon, where the two jets would be superimposed, it could give the illusion of what we observe with ORC-1 lobes of radio emissions overlaid with a host galaxy at center. Still, we require 3D simulations to assist us to figure out whether or not these specific AGNs are creating radio jets and whether or not we are looking at them head-on. Hypothesis 3. Starburst termination shock. The third and last hypothesis for an origin tale might be that the radio ring of ORC-1 is due to what's known as a starburst termination shock. In this scenario, millions of stars would have been created in a short, energetic burst of star creation in the elliptical parent galaxy. In this interval, new stars would have been born at a rate greatly exceeding the average and would have existed for only a few tens of millions of years an eye blink on the cosmic timescale. These stars would produce solar wind that spreads out into space over billions of years, exciting electrons and generating a spherical radio emission, bubble similar to the one we observe in ORC-1, although the team modeled this option in greater detail than the initial two hypotheses for the development of ORC-1 demonstrating mathematically how this situation was feasible. Norris was adamant that the evidence did not support this one more than the others. So although we do have a few good ideas, the source of ORC-1 is still as unexplained as the strange radio circle itself. More circles. As each new one was found, the only thing we seem to know for certain is that not all ORCs are created equally. After all, the name odd radio circles is meant as a descriptive name, like an umbrella term for any odd radio circle that can't be described by an existing type of object. So while all ORCs may include odd radio circles, each individual ORC may have its own unique origin story. The discovery of ORC-2 and ORC-3, the second and third odd radio circles to be identified, didn't do much to help solve the mystery of how ORCs are created. In fact, they introduced even more questions. Seen in this grayscale image, the two ORCs appear to be very close to each other, almost touching. They're about the same size, but on the right-hand side of the picture, ORC-2 is bright and distinctly ring-shaped, whereas ORC-3 on the left is weak and more disc-like. Indeed, ORC-3 will possibly not be discernible at all in the grayscale EMU image, if not for the light gray blotches appearing to group into a circular arrangement right next to the more obvious ring shape of ORC-2. Look now at this color photo of ORC-2 and ORC-3. The faint radio emission has been brightened up in red and superimposed over original radio pattern in green. You can see the hidden green color beneath the red glow where the ring shape of ORC-2 is positioned, and to the left you can see its dim sister circle of ORC-3, only seen in diffuse red. The closeness of these ORCs would imply they are somehow related, but if that's the case, why do they look so different? As much as I'd like to say to you that we've solved this intriguing case of ORC-2 and ORC-3, since their discovery published in 2021, the nature of these sister ORCs remains an unresolved enigma to date. Before we proceed to the theories for ORC-4's origin, I've got to say something about ORC-5, which was found in Australian Square Kilometre Array Pathfinder data in 2021, although we don't have any probable theories for ORC-5 specifically. This ORC was discovered to have a central, elliptical galaxy such as ORCs 1 and 4, and, interestingly, ORC-5 was the only one found to have both this central galaxy and a nearby, neighboring galaxy found at approximately the same distance from the ORC ring, which suggests these two galaxies are likely interacting gravitationally. While there may be some repeating characteristics for every ORC we've confirmed so far, it seems that every one of them is different. Of course, as we continue to find and verify more ORCs, it might be that this won't hold true in the future. But with there being so few ORCs and so little observational evidence, it's been hard for scientists to pin down one theory about how they came into existence. Cloverleaf ORC. And that brings us to ORC4, dubbed the cloverleaf ORC because of its irregular shape. Of course, this turned out to be another unique case. First identified in archival data from the Giant Meter Wave Radio telescope, the cloverleaf ORC would end up being the most extensively observed and imaged, unusual radio circle to date, having been seen in radio, X-ray, and visible wavelengths. Here in this beautiful picture of the cloverleaf ORC, wavelengths from a number of observations have been merged with radio emissions being represented as red optical wavelengths as white to yellow, and X-ray emissions as blue. This ORC is located some 600 million light-years from Earth and extends over 32,500 light-years wide, a bit more than 3 times as wide as our galaxy. In 2024, scientists at the WMKEC Observatory on Mauna Kea in Hawaii observed intense fluorescent light from oxygen atoms originating from the cloverleaf ORC, spanning 13,000 light-years of the ORC's enormous structure. This oxygen-2 nebula of hot, compressed gas, also referred to as shocked gas, appeared to have been formed by a high-speed explosion, said Allison Coyle, astronomer and astrophysicist at University of California, San Diego, who headed the research team that carried out this examination of ORC4. Because cloverleaf ORC, also Coyle, explained that one of the reasons could be that this ORC may have been created by a starburst termination shock event, a one of 3 theories for how ORC1 formed. The researchers could estimate the age of the stars within the galaxy in the cloverleaf ORC and discovered that they date back 6 billion years. Using this information and other figures, they simulated a scenario that demonstrated how the same kind of structure as the cloverleaf ORC can have been created by a starburst event that triggered a high mass outflow rate. Both the radio emission sphere and this gas nebula sphere might have been dispersed by the central galaxy by the supernova shockwave from combined explosions. This is a thrilling prospect, all because it is similar in nature to one of the ORC1 theories, but it's not the only potential. The same year, with the European Space Agency's Hypothesis 4, Galaxy Collision, XMM Newton X-ray telescope, an astronomers team led by researchers at the Max Planck Institute for Extraterrestrial Physics in Germany first observed diffuse X-ray emission from an odd radio circle, the cloverleaf ORC. From what they observed, the same team of astronomers who witnessed the X-ray emission, led by German astrophysicists Ezra Bulbul and Xiaoyuan Zhang, had speculated that the cloverleaf ORC could be associated with a cosmic dance of 2 groups of galaxies. The X-ray data indicate that the cloverleaf ORC would be the outcome of a turbulent merger of 2 galaxy groups that were gravitated toward one another. This is a form of a galactic merger, could have created shockwaves that would leave behind a gigantic bubble of radio emissions like what we've seen in observations of this ORC. However, a lot is still unknown, and it's unclear why this set of galactic groups would produce such an ORC, while other similar galactic group mergers do not appear to leave behind the same enormous bubble of radio emissions. The search continues. As it appears, the secret of how ORCs formed remains unsolved. In fact, it remains open to question whether the cloverleaf ORC is actually an ORC at all, given that it is more of a diffuse cloud and does not have the characteristic bright edges of radio emissions. Norris indicates that such cloverleaf-shaped radio clouds have been found in other groups of galaxies, not all of which are linked with ORCs. The secret to determining which objects belong to the ORC family and which are not is additional data. More radio and X-ray observations can perhaps assist in finding more intricate structures and assist in distinguishing between true and pseudo-ORCs. Fortunately, some other candidate ORCs have been found, and they can perhaps provide further data for astronomers to analyze and compare with the previously known cases. Now, instead of WTF, The side note on these strange radio emissions has a proper name, ORCs. But even though the jury is still out on how ORCs came to be, we're constantly gaining new insights from the likes of Project EMU and ASKAP. While studying EMU data for a nearby dwarf galaxy named the Small Magellanic Cloud, scientists identified the ghostly traces of two supernova, remnants that did not exist in the scientific records, expanding our list of celestial bodies. Besides those, one more local supernova remnant was discovered with the EMU survey in 2023 and proved to be one of the nearest supernova remnants to our planet at only 4,200 light-years away. This supernova remnant, titled This, was discovered to be approximately 130 light-years in diameter and is estimated to be only 13,000 years old. EMU has not only contributed to the discovery of previously unrecognized supernova remains, but it is also opening up the possibility of applying machine learning and the capabilities of citizen science to recognize and classify some 4 million radio sources, which may include ORCs, as part of a project called the Radio Galaxy Zoo EMU, or RGZ-EMU. At the time of writing 2025, the project has had over 2,000 volunteers and has assisted in classifying over 92,000 sources. But the best part? You can get involved and be part of this citizen science project yourself. To find out more, go to zooniverse.org and search for the Radio Galaxy Zoo EMU project. As our instruments become better and better, I expect that astronomers are sure to find more orcs and even more things we don't even know exist yet. We may find out not only how these radio rings were made, but we might learn something about the life cycles of galaxies, the impact of starburst activity, and whether we should be able to track gas from those ancient events all the way beyond their own home galaxy. Until now, though, the enigma of the source of these odd radio circles remains, though, with a number of hopeful theories. And to solve that enigma, cosmic archaeology on a scale almost too vast to comprehend will have to be carried out by astronomers. Figuring out the mystery of ORCs isn't simply a matter of tracking them down in the sky, it's a matter of digging through mountains of data, identifying tiny patterns and checking out ideas against the facts. Thanks for watching.